Well, we might as well get started. Thank you for coming this afternoon to this session on obtaining faster ROI with EAM, predictive maintenance, and industrial IoT. What I'm going to do is just give a little short introduction, basically just for 5 minutes, set the stage and introduce the speakers. Then we will have the three speakers speak, each for 20 minutes. And then the Q&A panel session. So we ask that you hold your questions, those pieces of paper that you can write your questions down and as the presentations go. And then we'll have the Q&A panel discussion afterwards. We'll ask you that you ask the questions then. David Littman here will have the mic, and he'll be running around. Now, we ask that somebody way over the left ask a question first. Second question come way off to the right, because I want to see how fast Dave could run back and forth. Just to give a little bit of an introduction, we have some of the speakers who will be talking about the topic of predictive maintenance, and other speakers who will be talking about EAM. Now, typically, the way the situation is today, we have process data coming off the equipment going into a SCADA control system, and typically your historian only has process data in it. That isn't a technical issue, it's just because it's connected to the process control information. What IoT adds is equipment data, which is distinct from the process data. So if we're talking about a pump, process data would be the pressure and temperature of the fluid going through the pipe around the pump. And the equipment data would be something like the current draw of the motor, perhaps, maybe a vibration sensor. And it's that combination of data that can give you a much richer assessment of the condition of the equipment for predictive maintenance. So it's one thing to generate an alert saying that things are starting to go bad and some action needs to be taken. But unfortunately, we found far too many cases where that alert gets lost. And the reliability folks are very proud that the equipment failed just as they predicted. Well, the whole point is to prevent the failure in the first place. So we have these separate silos, often separate from the reliability group, the maintenance group. So it's highly recommended that you have an integrated business process where the alerts go to the maintenance planner, who can then do some triage, establish priority, and take the high priority ones and turn them into a work order for a maintenance person to actually fix the system. So this makes a nice closed loop control system, which a lot of you who are control engineers probably really like this a lot. I know I do, all right? So that when a problem is identified, action is taken to prevent that failure. The second part of this is that you'll hear a lot of people talking about the integration of OT, IT, and engineering technologies. So I'm just going to a moment just talk about the IT-OT integration. This is an example, a real-world example of that IT-OT integration. The process data, equipment data, obviously, is coming off the plant floor, so that's your OT data. When you send that flag alert over to the EAM system, the EAM, the E stands for enterprise, that's an IT-type application. This is a real-world application of that instance of that IT-OT integration. So, the way this is going to work, we'll have the three speakers, starting off with Kate, then Dan, and then Tony. They'll each speak for about 20 minutes about their application and use of technology around IoT or EAM to achieve good results. They present their case story. Then when we go to the Q&A session, their technology partners will join the panel up here to answer any questions that may arise specific to their technology. All right. And with that, I'd like to turn this over to Kate.